Hello friends, welcome to Susan and John MathTube. This is lesson number 2 in exam preparation series for the first year engineering students. And in this lesson, we will learn how to trace hyperbola in the polar coordinate system. Now, as always, the first question: how to use these video lessons effectively and efficiently? And I'm sure you saw the same thing in lesson number 1, and I'm repeating it because this is very important. So point number 1, be ready with a pen and a paper, and point number 2, make sure you work out the problems along with us, and that's the only way to become more confident. And point number 3 and point number 4 is very important. Once you complete this video lesson, you can choose any book which you like and try to work out a lot of problems of the same type. And finally, test yourself. Collect some past year's question papers and try to work out similar questions. And if you're able to do those questions properly, that's it. You use the lessons effectively and efficiently. And with that, let's start today's lesson. So, as before, I have a question from 2073. Describe and sketch the conic r is equal to 12 by 2 minus 6 cos theta. And one very important thing, if you are watching this lesson for the first time without watching lesson 2, I'll strongly recommend pause the video right now and watch lesson number 1, because it's just a continuation. And if you don't watch lesson number 1, you will not understand many of these things. So let's start. So whenever you're given a conic like this, what you do is you make this into 1. So what we do first is divide throughout by 2. So 12 by 2, that is 6. The whole divided by 1 minus 3 cos theta. And then what do we do next? Comparing with dE by 1 minus E cos theta. In the last lesson, we learned about the 4 different equations, 2 with cos and 2 with sine, with plus or minus over here. And now we compare. So D into E is equal to 6 and E is equal to 3. So E equal to 3 means it's a number greater than 1, and which implies the given conic section is a hyperbola. Now we plug in this value of E here. So D times 3 is equal to 6. So D is equal to 2. Now D means the distance between focus and the directrix. So the distance between focus and directrix is 2. And the last thing that you must write in your exam paper is one of the focus will be the pole, that is 0, 0. Remember, we are not in the Cartesian system, but in the polar coordinate system. In the Cartesian system, we call the meeting point as origin, and in the polar coordinate system, this point will be called the pole, and the coordinates will be 0, 0. Okay, now the next thing and the most important thing, we have to collect 4 points. So we plug in values for theta, and we use theta to be 0, 90 degree, 180 degree and 270 degree. And you can plug it in the given equation or the simplified equation, it's up to you. So we get r is equal to, so when we plug in 0 degree, we get cos 0 is 1, you can use the calculator. So 6 by 1 minus 3, that will be 6 by minus 2, that is minus 3. So when we plug in 90 degrees, we get 6, and cos 180 being minus 1 will make it 6 by 4, and that is 3 by 2, and again we are going to get 6. So that's it. But before we plot, for the students who forgot things from class 12, I'll remind you, a hyperbola looks like this, and the reason is we have cos theta. If the equation contains sin theta, our hyperbola will look like this. Anyway, let's forget about this for the time being. And the focus will be here. One will be over here and one will be over here. And these are the vertices. And the directrix will be in between the two curves. And of course, the center will be at the middle. So remember, this is the structure of a hyperbola, and you have to find all these things. We have to find the two foci, and of course you know that one of them will be the pole. And then we have to find the two vertices and the two directrix, equation of the directrix, and finally the center. Okay, so let's try to plot. Okay, so look at this. We have the pole and the initial line. So immediately you can write one of the focus is the pole. Okay, now let's plot the first point, 0 degree minus 3. I hope you still remember the logic. 0 degree means this direction. And this is positive. And if you move in the opposite sense, you'll get 0 degree but negative. So 0 degree minus 3 will be, you have to walk in this direction, minus 1, minus 2, minus 3. So it will be somewhere here. Okay, so this point is minus 3 comma 0 degree or 3 comma pi. Last time I told you, here the points will not have unique representation. So the next point, 90 degree 6. So from here you have to take a reference of 90 degree in anti-clockwise direction, and it is positive. 90 degree positive means in this direction. 90 degree negative means in this direction. So it's positive. So 1, 2, 3, 4, 5, 6. In exam, when you try to plot these things, always use scale, pencil, etc., etc. So the third point, 180 degree 3 by 2. 3 by 2 is 1.5. So first we turn 180 degrees and then 1.5. So it should be here. So I forgot to write this. 6 comma pi by 2, and this is 3 by 2 comma pi, and the last point 270 degrees. So here, so we go down 1, 2, 3, 4, 5. Okay, it will be approximately somewhere here. Now I'll erase these things. Okay, now I want you to focus on these cross, one and another one here, and I'll put a cross over here. So look at this. Once you plot these 4 points, you'll be able to see one side of the hyperbola, either this side or this side. I'll repeat, 3 of the points will be on one side of the hyperbola. Anyway, I'm able to see the hyperbola now. So I'm going to plot the hyperbola. And here, I hope you're able to see the hyperbola. It goes like this, it goes like this, and that's it. I can make it a little bit thick. Okay, so remember, you'll be always able to see one side of the hyperbola, either the right or the left. Now, for the other side, you have to use the symmetry. You just make it in such a manner that it looks like the mirror image. That's it. The hyperbola is ready. But we have to find a lot of things. Now look at this. Clearly, we have the vertices. This is V and this is V dash. And we have one focus. Now look at this. This distance from pole to this vertex is 3 by 2. That means 1.5. So if you want the next focus, all you have to do is you have to move 1.5 units from the next vertex. So the next pole will be here at this point. Now look at this. From we measure everything from the pole. From here to this point, it is 3 units because the coordinate is minus 3 comma 0. So this blue line, this much is 3 units. And then I added 3 by 2. So I came forward, so 3 by 2 more. And that makes it, I'll make it a little bit clear. This is the vertex, and that is minus 3, 0. Okay, so once more I'll tell you. So the length of the blue line from the focus or the pole will be 3 plus 3 by 2. And that gives me 9 by 2. So the next focus is 9 by 2 in the direction of pi. So now we are ready with both the foci and the vertices. Now what's left? Yeah, the directrix. So D equal to, do you remember D? Okay, let's check it. Yeah, D is 2. So from focus, we have to move 2 units. So this is 1 and again 1. Okay, that will be our first directrix. So let's plot that line. So this will be our directrix. Okay, now from the next focus, I have to move, what is D? Yeah, D is 2 units. So I have to move 1 and 2. So there will be my next directrix. So let's plot the next directrix also here. Okay, so I hope you're okay with the directrix. Now to find the equation of the directrix. So look at this. If I want to reach the directrix, I had to turn 90, 180 degrees. And then I have to move 2 units in this direction. So the equation is x is equal to 2 cos pi. I explained very clearly in the last video how to write the equation of lines, I mean standard lines, parallel to the polar axis, perpendicular to the polar axis, etc., etc. Okay, now the second line. So that's also in the direction of 180 degrees, but now we have to measure. So look at this. From the pole to this focus, that is 9 by 2. And then what I did is I returned 2 units backwards. I'll repeat. From pole to this focus, it is 9 by 2 units. And then what did I do to find the next directrix? I went back D units. So this equation will be 9 by 2 minus 2 in the direction of pi. So cos pi. So 90% of the problem is solved. Now one more thing is left, that is the center. Center is very easy to find. So center will be the midpoint of the vertices. So look at this. From focus to the first vertex, it is 3 by 2 units. And from focus to the next vertex, it is 3 units. So the difference between them is equal to 3 by 2. I told you, if you want to find the midpoint of a line segment, and if you know the length, let's say this is 10 units long. So if you want the midpoint, you just find 10 by 2 and move from any end and you'll reach the midpoint. So what is half of 3 by 2? 3 by 4, and that is equal to 0.75. So from this end, I'm going to move 3 by 4 units backwards, and that will be the center. I hope you're able to see that center. So the coordinates of the center is, it's in a mess now, so I'll write it here. 3 minus, look at this, the total length is 3. This is 3. And I went back 3 by 4. comma pi. That's it. I hope you got a rough idea about how to plot the hyperbola. Now let's try to make it clear with one more question. Describe and sketch r is equal to 12 the whole divided by 2 minus 4 sine theta. So what to do first? We have to make it 1. And to make it 1, we have to divide throughout by 2. So this becomes 6 by 1 minus 2 sine theta. And then comparing with the standard equation dE by 1 minus E sine theta, we can find dE to be equal to 6 and E is equal to 2. But 2 is greater than 1, and that implies the given conic is a hyperbola. Now you plug in this value so that we get d is equal to 6 by 2, that is equal to 3. That is, the distance between focus and the directrix is equal to 3. Now last comment you have to write in your exam paper is, clearly one of the focus will be the pole and then the box. So you plug in values for theta, that is 0, pi by 2, pi and 3 pi by 2, and you can find the output r. You plug in the values, sine theta, sine 0 is 0, so you're going to get 6, and sine 90 is 1, so 1 minus 2, that will be minus 6, and sine 180 is again 0, you're going to get 6, sine 3 pi by 2 is minus 1, so 6 by 3, that is 2. Okay, now we are ready to plot. But before that, one more comment. You see sine theta. So we must expect a hyperbola which looks like this. And remember, the foci will be over here, the directrix over here, and the center is here, and of course the vertices are this. So let's start. Okay, so we have the pole and the initial line, and I'm so confident that I'm going to write this is one of the focus. Now let's start to plot. 0 degree 6 units. So it will be somewhere 1, 2, 3, 4, 5, 6. I'll put a cross. And then 90 degrees minus 6 units. Look at this. 90 degrees means this is the direction, but it is minus 6. So minus 1, minus 2, minus 3, minus 4, minus 5. So somewhere around here. And then 180 degrees 6 units. So 1, 2, 3, 4, 5 and 6. Okay, and finally 270 degree 2 units. So 1, 2. Okay, I'll put a cross. Okay, now look at this. As I told you before, I'll erase these dots so that you are not confused. I'll even erase this. Okay. So, now I hope you're able to see 1, 2, 3, 4 points. And I promised you something. You'll be able to see one side of the hyperbola. And look at this. I'm able to see this part. So let's have a rough figure. So the hyperbola is ready. Now for the other side, you just use symmetry. Just draw as if you're making a mirror image of what you see on the top. And that's it. The hyperbola is ready. Now we have to find the coordinates. So this is the focus, and this is one vertex, 2, 3 pi by 2, and this is another vertex, minus 6, pi by 2, and these are 2 points which helped us to draw the picture, so they are not important. I'm not going to write that. Now the next thing, are you able to see the distance between this focus and this vertex? 2 units. So to find the next focus, it is very easy. Go to the next vertex and move 2 units down. So this will be the location of the next focus. Now for the measurement, we have to measure everything from the pole. So from the pole to this, I know it is 6 units. And I am adding 2 more units. So the point will be 8, 3 pi by 2. Okay. Now the next thing, so we found the focus, directrix. Do you remember D? Yeah, the value of D is equal to 3. That means from the first focus, I move, this is 2 and 1 more unit. So my directrix, first directrix will be here. So this will be my first directrix. And for the other directrix, I have to move to the next focus and 1, 2, 3. So it will be somewhere here. Okay, now the equations. So look at this. The distance from focus to this line is 3 units. And to reach the line, I had to turn 90, 180, 270. So the equation is y is equal to 3 sine 270 degree. Now, the distance from the pole to this line is actually, how do you calculate? So, look at this. I know this distance is 8. And then what did I do? I subtracted 3 units. So, this equation will be y is equal to 8 minus 3. It's in the direction of 270 degrees. So, sine 270 degree. That's it. Okay, now only one more thing left, that is the center. Now look at this. I'll use another color for your advantage. So look at this. This much is 2. And from there to the next vertex is 6. So 2 and 6. The difference is 4. So 4 by 2 is 2. That means I know that my center will be 2 units from this vertex. So I go 1, 2 and this is my center. And if I measure from here, this is 2 and again 2. So the center is 4 in the direction of 3 pi by 2. That's it. So you learn how to plot a hyperbola. One more question which they asked long back. I'm not going to solve it, but it looks like this. They asked in 2073. So remember, the first thing to do is to convert everything into sine and cos. So I'm going to divide throughout by cosec theta. And we know that 1 by cosec theta is sine theta. So the equation becomes 10 by 2 plus 3 sine theta. And next thing to do, you have to make it 1. So R will be 5 by 1 plus 3 by 2 sine theta. Now you write comparing with dE by 1 plus E sine theta. So you get E is equal to 3 by 2, which is bigger than 1, so it's a hyperbola. That's it. Now I want you to plot this graph and check whether you're able to describe and sketch the hyperbola. So the hyperbola looks like this because we have sine theta over here. I'm going to wind up this video right now, and if you like the video, please share, like and subscribe. And in the next video, we will learn about differential equations, and we'll be going through a very important type, that is capital D type problems. So till then, bye.